Good morning and welcome to part 4 of Online Math Thinking Fundamentals, the series where we learn how to learn like a mathematician. Today's topic is variables. At least I think it was, unless it's changed. Oh, good, it's still there. Now, this is the part where we're going to start getting a lot more abstract in our mathematics. The idea of variables is simply this. Sometimes I don't know what the number is, but I still want to be able to do my math operations to figure certain things out. Now, do not confuse this with your basic Algebra 1 solve for the variable. That is a part of it, but it is not the whole thing. Okay? Let's start with what a variable is. Everybody loves good old x, right? That is our variable. Solve for x. What is x? X could be a number, but it could be more than that. So what I really want to use to describe variables, I'm going to borrow an analogy actually from computer programming. We're going to say that variables are more like a box. Okay? And you can have your basic cardboard box with little flaps on it, right? And that box will be labeled X, but I can put anything inside of it. I can put a number, let's go back. Let's use our number 4 here, and we can insert that 4 into the box. And now X represents 4. When we look at the box, we see X, but we know inside, secretly, is the number 4. But it doesn't have to be numbers, okay? They can hold anything. We can have our variables hold numbers. They can hold other letters, right? Any value can be stored in a variable, okay? Once again, this is really critical to computer programming, where everything just about is treated as a variable, okay? Such as the color, right? The fact that I'm using orange here, my iPad knows orange is being stored in the variable color, right? Or pen color, if you want to be more specific. In fact, variables can have any kind of name. It doesn't have to be just one letter. If you really want to push the boundaries of your mathematical thinking here, I invite you to try some math problems using more than one letter as the variable name. Don't solve for x. Solve for the variable blob, right? I love this example. This was from Cool Math, not Cool Math Games, coolmath.com. Uses this example. What it happens when you take, blob squared, right? And that is not b times l times o times b. That is all one word. That is one variable. Treat it as such, okay? It can hold any other value, whether that be a number or a color or some other name, some other word, right? The country of origin, right? That might be a variable that you would see, right? Load up the Wikipedia page for anything, and on the side there'll be the quick fact box right underneath the picture and all that stuff, and you have country of origin. That'll be a variable that changes per page as you go through each one, right? It'll have a different one. There, that's a variable. That is a mathematics concept because it allows us to become more and more abstract, right? We are going towards the abstract. Why would you want to do that? What's so great about more abstract math? I thought the purpose of math was so that cavemen could start doing commerce, right? Yes and no. Pardon me, I'm going to drink a tea. The abstract lets us deal with the unknown, right? You might have heard that referred to. Solve for the unknown variable. The part that you don't know yet. Think back to ancient civilization, dawn of civilization, the beginning of farming, settling down. You want to plant your crops, wait for them to grow, harvest them. Ideally, next year, plant again, right? How do you know how much food you're going to need? How many people are there? How many people will there be next year? You got to feed all of them, right? Some people will die off, other people will have more babies, right? The population is in flux. You have to plan ahead. You don't know. There is an unknown. Thus, the need for some abstract math. And I'm using the term abstract a little loosely. It does have a specific categorization of mathematics here, but bear with me. Right? We're talking about unknown things, right? Having to imagine more stuff. You cannot sit out there and count and visualize these things as a number because I don't have them yet. To me, that seems pretty abstract, right? But it allows us to make predictions, okay, about the future. If we can still do the math, still make the computations and those calculations of how much grain we need based on the number of people in the society, right? And that number of people changes, well, then I can directly see how the amount of grain I'm going to need changes. How much food I will need. Oh, if the population doubles, I'm going to need twice as much food. And that simple relationship, oh, there's that word again, right? It sounds pretty basic to us, but remember, somebody had to figure this out for the first time. They had to deal with the fact, oh, shoot, what are we going to do next year, right? Getting through this year was hard enough. What about next year? Oh my gosh. How can I plan for that? How much food am I going to need? Well, the answer is always, right, it depends. Right? How often have you heard that one? Right? You ask a question, it depends. Depends on what? That's what variables allow us to do. They tell us exactly what things depend on. Right? This is why they're called independent and dependent variables. Let's see what I did today with the y and the x and the independent. Yeah, okay. Anyways. Okay? It depends on something. We have a need as people doing math, using it for the advancement of civilization, right? We have a need for these ideas to depend on other ideas, okay? And it's not just talking about the relationship itself, that describes how it depends on, but we have the fact that it depends on it at all, right, is a more abstract idea. And that one thing could be different or could be unknown, but we still want to know the relationship. Thus, we need variables. And starting in algebra, well, pre-algebra, as it were, you're going to be dealing with variables. You're going to be dealing with math, and it's like, what happened to the numbers? When did they start adding letters to it? Oh, it's so confusing. It's not. It's not any more confusing if you think in terms of ideas. If you get latched onto the specific objects, you're obsessed with this has to be this. A 4 is always a 4, and I can only deal with 4 at a time, then yes, you will be stuck. But remember, the 4 itself has a whole bunch of ideas associated with it. That's why we created that idea web. The 4 has a bunch of relationships with other numbers, with other ideas, ways it can combine with other things. Those relationships, okay, don't change just because it's no longer a 4. Just because the 4 is invisible, or because your 4 is hiding in a box now, it doesn't lose its properties, okay? We might have to become a little bit more abstract as we go because we don't necessarily know it's a 4. I can't say that this box labeled X is always even if I don't know for a fact that it contains 4. Okay? So that's one property you can't rely on as you're using the X. Okay? But you can rely on all those operations, right? We can still add, subtract, multiply, divide, take the inverse of, and I can represent those in an abstract manner. We can still write out x minus 2. Okay? We can still use that even if we don't know what x is. And that is the goal, to be able to still do math even when you don't know some parts of it. It gets down to the abstract ideas. We're working with ideas mentally in our head rather than the distinct objects that I can look at, that I can count, that I can see sitting there before me. Okay? That is the next level, the next stage, if you were, of mathematical thinking. Being able to hold an idea in your head even when, and especially when, it doesn't quite make sense yet, because you don't have all the pieces. More pieces coming. That's going to do it for this video. Thank you so much for watching. So long, farewell, enjoy the rest of your day.